90380 relay for heating and air conditioning or HVAC uses. Question one may wonder what is a relay for and what is the purpose of a relay? There are many reasons to use a relay, but normally a relay, in simplified terms, may indicate that one wants to turn something off. For instance, they have the line voltage and the load voltage. The load voltage could be, say, a blower motor, etc. So anyway, your line voltage feeds to your load. So anyway, what happens here when one goes to turn this on and off, say if one grabs a light switch with their finger, their index finger and their thumb, and they flip the light switch, well, the one position may be off, the other position may be on. So you flip it if you want it on. If the lights are off, you flip it up, perhaps upward, and the light may come on. So in this particular case, though, the relay, what it does, it allows it to, the thermostat may sense temperature in the room, and hypothetically one may have set the thermostat, whether that be the homeowner, the HVAC tech, or do-it-yourselfer or whatnot, may set the temperature inside of the room to come on at a certain point, or just manually set it to the fan mode. So once the fan mode is set, there are two low voltage wires. One, say, the green wire may feed here, and the blue, the common wire, may feed here. So, for instance, when it's called for fan, say if one of these relays may be normally open, this one may be normally open, and this one may be normally closed. I'm not certain. And if the HVAC gurus could add this to the comments, what would be the uses of a closed, say the terminals that would be closed within here, if they could add this. Now the normally open, it's kind of a no-brainer. So the voltage comes to one side. This voltage here does not reach here unless this is energized. Once this is energized with 24 volts, then the normally closed relay becomes a normally, becomes a normally open relay. Let me rephrase that and correct myself. The normally open relay becomes, once this is energized, may become a normally closed. So if there's no power here, this particular relay, this particular terminal here may hypothetically look something like this. But if this is powered here, then this becomes here, and the voltage is allowed to go across. So if you have a one wire going to your blower motor, your HVAC blower motor, then you have another wire. So you're picking up, say, if it's a whatever voltage that may be, either 120, 240. So if you split one of the wires here, this means when this is de-energized, this goes off. Which, if we had a fan here, this would, you may ask, well, why would you want it to go off? Because if it doesn't go off, it's going to run incessantly, and this fan's going to burn up over a period of time. So this relay helps turn it on and off. And the relay can be controlled perhaps by your thermostat coming down here and sending a 24-volt signal to the coil. And then the coil, say if this were a normally open relay, would close this relay here. So if we have a multimeter here, and we put the multimeter on the, the continuity settings, which is the little setting with the speaker looking gadget here. So we got it. We have the backlight on. So now if we go over here and we touch this terminal and this terminal, that means that's a closed circuit because we're getting the beep. Okay, if we go here and here on this terminal, we have nothing. Because what happens, this may be a normally open circuit. So if you wanted to just to test the relay, this is just cursory way to do this. So basically now, if we energize those bottom two terminals with 24 volts, then perhaps this would, this may give us the noise with the beeping from the continuity setting. So if we go back here, this is a normally closed, so we're making a full circle and you hear the beep. Then a lift up, then you hear the beep again. Go back here, nothing, because this is normally open. This is not a complete circuit. And so this would tell you once this is energized, this would close. So then this noise you're hearing here, you should maybe perhaps be able to hear it here. If we jump over here, there, that's a closed circuit. Or if we do it this way, if we take our leads and touch our leads, that's a closed circuit. So this is just a quick way to test a 90380 relay, and then you can tell which terminal's open and which terminal's closed. So we put this back on here. That terminal would be closed. We move it to this terminal here. That terminal there would be open. So when this is energized with low voltage, 24 volts, say hypothetically the green wire and the blue wire, the common wire, then once it's energized, this should close, and this should allow electricity to flow from one side to the other to feed the load side, whatever that may be. If that's a blower motor, that would be a blower motor. Now, one may ask, well, why would you even use this? Well, if you don't have something like this in between, then if the power's running continuously through here without a break, then the motor just incessantly just runs. So once these two terminals are de-energized, then the motor would go off. Now, one question I have, and this is for the HVAC experts, what would be a good use of this in HVAC on this normally closed terminal? What would be a good application? And if anybody has a great answer for that, that would be wonderful. But see, this particular terminal here is normally closed at all times. That's a full circuit. We go here, and this is normally open. But if the HVAC, this is kind of a no-brainer. This turns the power on and off. But what uses would these two terminals be that would be normally closed, if somebody can add that? And I feel certain there's got to be a use for them, otherwise they wouldn't be there. But if anybody can add that. But just a quick way to check a 90380 relay with a continuity from the, from a multimeter. Thank you for watching. Have a great day.